What did we discuss last class, first of all? If you remember, one of you.
Data cleaning,
Yeah,
like
data. Yes. So what were the techniques, what we discussed? Do you remember something? Some names?
binning,
Mm.
then min-max normalization, Z-score normalization.
Yes. Anyone else? Anything what you remember from previous day's class? I think I'll call. Harshit, are you here?
Yes, ma'am.
Anything what you remember from previous class, can you tell me?
Yes, ma'am. You gave an example of future extraction in face recognition as an example for data processing, ma'am.
Okay. Pranati? Sai Pranati, are you here?
Yes, ma'am.
Can you say me something what you remember from the previous day's class? Anything what we discussed? You're saying something I can't hear.
No, ma'am.
Ashwin, he just joined, I guess. Ashwin, are you there? He'll be thinking why I joined. Gayatri, are you here? Yes. Do you remember something from previous class?
No, ma'am.
Why? Was it very tough?
I didn't attend last class.
Okay. But you could have just listened to what was there, right? Suddenly you all will prepare for your tests. Huh? Manasa, are you there, Manasa?
Yes, ma'am.
Yeah. Do you remember something from the previous class? More than half doesn't attend the class, and those who are attending also, I don't know whether you all are here. Anyway, please go through the slides and the materials. If you have doubts, please get back. Otherwise, just before test, if you start looking, it will be difficult for you. Okay, let us start anyways. So now today we are just, I'll just share my screen. Yeah. You're able to see my screen? I think it's loading. Okay, we'll wait for a second. Is my screen visible to you all?
Yes, ma'am.
Yeah. Okay.
Yes.
Yeah. Thank you. I think I have started recording, isn't it? It's on, right?
Yes, ma'am.
Yeah. Okay. Thank you. So let us see today just regression. So if you remember, I think in the initial classes when we discussed about supervised, unsupervised and all, we talked about regression. So is the regression supervised or unsupervised model?
Supervised, ma'am.
Yeah, supervised. So under supervised, we had classification and regression, isn't it? So what is the difference? So when we have, we are going to predict what we are going to predict, the prediction what we are going to make. If it is discrete or categoric, we used to say it is classification. Whereas if it is continuous valued, like say it can be price, it can be temperature, so it can be any value, any continuous value. It is a continuous value. So if that is the case, then we say it's regression. Okay. So if we are going to predict some continuous values, okay, but still it is supervised, so we have the data. So we learn from the data. Say for example, we have say land size of the land, okay, and then in square feet or something, and then its price. So if we have say 1,000 data like this, now we try to build a model, and then when you get a new data, that is a new land size, we'll be able to predict the price, okay, because you have trained the model using previous 1,000 values of price, and it learns, it tries to fit some model and then tries to predict when you get a new sample. Okay. So now let us see what is this linear regression. So it is mainly for predicting the value of a dependent variable from the independent variables. And it is usually to capture the relationship between continuous features like say price and size, etc. So finally your output variable should be a continuous variable. Only then we go for regression. Okay. And then so say for example, Sam found how many hours of sunshine versus how many ice creams were sold at the shop from Monday to Friday. Okay. So y, your output variable, is dependent. Now, since you see numbers like this, you shouldn't feel that it is discrete. We are just showing some 5 samples. If you see the entire data set, it can be anything, any number. Okay, it may be like till 1,000. So it is like continuous. Okay. So then we understand that, say for example, from this data, like it is supervised because the output variable is also given, how many ice creams are sold are also given to the model. Okay, say for example 1,000 data like this is given. Now say tomorrow, like say for example, Sam is getting a new information, like tomorrow 8 hours of sun would be there. So we know X. Now we need to predict how much would be sold, so that he'll know approximately how many ice creams he need to keep, etc. So that's all. Usually it is for like say temperature or price, stock market price, or all those things. Okay, this example is simple. That's all. So usually when we have we are now currently considering only one attribute. Okay. So if you see here, X is the attribute, Y is our prediction variable. So X is the independent variable, Y is the dependent variable, you can say. Okay. And we are trying to build a straight line, construct a straight line, so that we can predict when we give we try to establish the relationship between this X and Y. And then when you get a new X, we are going to try to predict Y. So that is our intention. So we all know what is Y equal to mx plus b. That is the line equation. Okay. So m is the slope, b is the y-intercept. Okay. This formula, what is written below, you can either use this, or I have another formula coming up. You can use that also. Very similar. In both cases, we'll get the m and b. Okay. I would prefer the second one, because always we may not directly use the same formula like y equal to mx plus b. Though it is that same form, we might write say y is equal to w naught naught x1 x plus w1, or we might write say theta naught theta1, something of that sort. So in different books you may see different, but finally you should understand it is all forming, it is all from the base of your equation of straight line. It is the same. So now let us see just an example. So here, if you can see regression data point X, in actual situation, you will have multiple attributes. Okay. So you have many attributes and corresponding Y labels. Okay. Sorry. So currently what they are showing is just one X. Okay. Different values of X. Okay. And corresponding Y values. Okay. That is all. So as of now, we are considering only one particular attribute. Okay. So then corresponding Y labels also given. And then we try to, so our blue in the figure, if you can see, the blue dots are our points. Okay. X, Y plotted across X and Y axis. So we have certain points. Now we try to fit a linear straight line. Okay. That is our red line, in such a way that there is minimal error. We'll see what is that minimal error, etc. But then we try to fit a best line. Okay. So here, don't think like we are going to separate a positive class, negative class and all. We don't have that. We are trying to fit a line in such a way that when you get a new x value from the equation of this line, you should be able to predict the y value. So that is our intention now. Okay. So they have even given a quadratic regression, like it's a not just a linear one. There can be other regression too, which might be better in certain cases. But now initially we are just concentrating on linear regression, just a straight line. Okay. So let us see, this is the formula what I was talking about. So when we say linear regression, we have a response. We say it as response variable, target variable, etc. for the y. Okay, and assuming we have a single predictor variable or the input attribute, which is x. Okay, for the linear regression. So now we know that if you think about your y equal to mx plus c, you know that theta 1 is the slope and theta naught is the y-intercept. Okay. Now, using the methods of least squares, okay, how to come up with the best straight line. This is the formula for that. Theta 1 is sigma xi minus x bar. X bar, you know that it is the mean. Okay. And into yi minus y bar, the whole divided by sigma xi minus x bar, the whole square. Okay. So thus we can get, so this is called methods of least square, and thus we can get theta 1, and applying in the equation, that is the first equation which is shown here, just make it a point. So using this equation, okay, so substituting the theta 1 in this equation, we'll get theta naught. Okay, so that is y minus, so y bar minus theta 1 x bar. Okay. So then we'll get the theta naught also. Now this would be our theta naught and theta 1. Okay. So because we need to know what is the best, what is the best line, isn't it? We need to know what is the line, so that when you get a new value, we can predict. Okay. So this is very simple to calculate. Can we just solve one problem? So when we say methods of least squares, we are just finding theta 1, theta naught using the least square method, that is this formula. Okay. And which is similar to the previous slide. If you see, we'll get the same value. Okay, it is just little different in calculation. So if you find theta naught and theta 1, then if you write y is equal to theta naught plus theta 1 x, okay, that is your line, what you have formed, equation of your line. So can we just, this is your data. Can you tell me what would be theta naught? Sorry, theta 1. Is it possible for you to calculate? Can you try now? Otherwise, I think you will later on not see how to try. So one of you can just, each of you can try for different values. So what all we have to find? What is our formula? Can one of you just tell, you want me to show what the formula? You can note down, that is sigma xi minus x bar into yi minus y bar, the whole divided by sigma xi minus x bar, the whole square. Okay. So this is for theta 1. So can somebody find xi minus x bar? If you can use Excel, it will be quick than calculating, because all of you are in front of the system. Can one of you find out xi minus x bar value? Can somebody else find yi minus y bar and tell me? Who will tell me xi minus x bar? I want to know. It is just xi. First you should find x bar and y bar. So maybe somebody should find that. Just type this in Excel and then just can somebody try and tell me what is the value?
X bar 5.2.
Yeah, x bar is 5.2. Okay, y bar?
7.4.
8.2, ma'am.
8.2. Yeah, I think you have made a mistake. Yeah. It's better to calculate in Excel, I think, because your xi minus x bar, etc., you can calculate quickly. Now so your x bar is 5.2. So please calculate. Don't sit. Anyway, you are wasting this 50 minutes, isn't it? You are coming to the class and you are sitting here. So like our usual class, you try solving it. So can somebody, so x, you know how to find the mean, isn't it? Just average it. So add it and divide it by 5 because the total number is 5. So x bar is calculated as 5.2, y bar is calculated as 8.2. Now can somebody say what is xi minus x bar for each of the values? For first value, can somebody say me what is the xi minus x bar? You have xi as 2, x bar as 5.2. What is x minus x bar? What is there so much to tell? I'm not asking the sigma. I'm just asking xi minus x bar. The first x
minus 3.2.
minus 3.2. Okay. What about the next? The second value of minus 2.2. So first one is minus 3.2. Next is minus 2.2. Then
minus 0.2.
minus 0.2. If it is Excel, it is just a click and drag. That's why I told. That's better. Anybody else? I am hearing the same voices. You can just try. This is normal mathematics what you all have tried. I'm not telling anything new. Xi minus x bar is what you are writing now. So minus 0.2 somebody has told. Then for 7, the value x as 7. That is the value I'm talking. Yeah, sorry.
1.8, ma'am.
Correct, 1.8. Then
3.8.
3.8, correct. So we have xi minus x bar. Now we need to find yi minus y bar. Has somebody found out yi minus y bar? So the first y is 4 and your y bar is 8.2. So 4 minus 8.2.
Minus 4.2.
Minus 4.2. The next one.
And we are getting answer as 0 now, ma'am.
No, for what? We are not finding sigma of xi minus x bar. We are finding the sigma of xi minus x bar into yi minus y bar. That term sigma only we will find, not this.
Yeah,
For
yes,
this,
ma'am.
actually, if you find sigma, you will get 0, but that is not our intention. I'll show you the Excel. Actually, it is not there in the slide. I'll put it in the slide. They have used a different, little varied formula. That's why I'm not showing it. So can you find out the next terms yi minus y bar? After that, I'll just show the screen.
Ma'am, minus 3.2, minus 1.2,
Yes.
1.8,
Yes.
6.8.
Yes. So I'll just share my screen. Okay. It is not put properly. I'll do it. I mean, I'll just make it proper. The headings are not there. But just for your understanding, I'll just show you the values, how we calculate. Is my screen visible?
Yes, ma'am.
Yes. Okay. So the first, this term now highlighted is your x. Okay. Now this is your y. Okay. Your x, sorry, mean of x, that is x bar is this 5.2. Okay. And then this is your y bar. Okay. Now what is xi minus x bar? These are your xi minus x bar. Of course, as I think Vikas mentioned, I don't know who mentioned, I think it's Vikas. So one of you mentioned that when you find the sigma of xi minus x bar, it is 0. But our intention is not to find sigma of this. Okay, we are not finding anything. So we just find xi minus x bar. So that is this. These are the xi minus x bar. Then we have yi minus y bar. Okay, that is also calculated. Now if you can see here in this column. Okay, I'll just write say xi minus x bar. I am writing xm, which is assume that it is your x bar. Okay, so xi minus x bar into y minus y bar. That is this column. This column, what you see is just multiplication of this. This sigma you should be finding. Okay, that is your numerator. Okay, is that fine now? Because okay, so your terms are xi minus x bar, yi minus y bar. You are calculating for each terms, and then your summing, you're multiplying them. That is xi minus x bar into yi minus y bar is calculated. That term you are summing. Okay, that is your sigma, which is your numerator. Okay, so that is 49.8. Okay, what was the denominator? Xi minus x bar the whole square, isn't it? So xi minus x bar is here. Okay, so we are finding the square of each of those. We get x, like you had minus 3.2, minus 2.2, etc. For each term, you're finding the square. Now you find the sum. Okay, that is 32.8. So this is our denominator and this is our numerator. So it is 49.8 divided by 32.8. So what are we calculating? Theta 1. Okay, so our theta 1 is as 1.5. Is that fine? Any confusion in calculating this? If you have anything, we'll once again discuss. Is this clear?
Yes, ma'am.
Yeah. Okay. So I have some issue with my keys. That's why some alphabets don't come properly. That's why suddenly if I type, it may not come. So I'll just write theta. So our theta 1, okay, is this 32.8, sorry, 49.8 and 8 divided by 32.8. Okay, so that's our theta is 1.518. Now, how can we calculate theta 0? Theta 1 is this. Okay, let me write like this, theta 1. Okay, how can we calculate theta 0 from this? I'll just unshare. So now we have calculated theta 1. Okay. Now how do we calculate theta 0? We already have this, isn't it? Theta 0 is equal to y bar minus theta 1 x bar. So can you tell me what is theta naught? You have y bar, you have x bar, you have theta 1 also. You got? Somebody got? I think somebody switched on their mic. Did you get the value for theta naught?
Ma'am, 0.304.
0.304. Okay. So let us see whether the value is correct. The PPT is visible to you, right?
Yes, ma'am.
Yeah. Okay. So this is the value we came, the steps you just ignore. Okay. So finally, we are getting the value of theta naught and theta 1 as, I'll just change this slide and give, okay, don't worry. So better to follow this method, what I showed. So finally, we have theta 1 as the last line you can see, okay. We have our theta 1 as 1.518 and theta naught as 0.305. Okay, so our equation we can write it as y equal to 1.518x plus 0.305. Okay, did we get an equation now? Yes. Now can we write for each value what is the predicted value? That is, this is our model. Okay, we have built a model. It is a straight line. It can be anything, isn't it? So now we have built a model and we are checking and we are going to predict. We know the x values, like previous slide we had x values 2, 3, 5, 7, 9. Okay, we actually know the y values also, but let us try predicting it using this equation of line what we constructed. Okay, that is our model. So we are trying to predict using our model. So what could be, how will you predict one value? Can you just try and tell me how you will calculate? You just need to tell. So first value is 2. How will you find the y? You need not tell the answer. Just tell me how you will find. Very simple. You're just substituting, but at least tell that.
Ma'am, basically substitute x as 2 in that value.
Yes, correct. That's all. So 1.58, sorry, 518 into 2 plus 0.305. So you may get a value called 3.34. So if you can see, okay, this column, okay, this is all predicted using this line equation. Okay, that is our model, what we built. Okay, we were given certain points and we try to fit in a line in that particular points, and that equation we have obtained. Now we are trying to substitute the values for it. Okay, and then what happens? There are some errors, isn't it? You know the actual values, okay? And now we know the predicted value of y. We know the actual value of y. You understand that there is some error for each of the values, isn't it? Okay, let us keep that there. Okay, we are not now concentrating on how we are going to find the error, etc. But assume that this is the best model. Okay, this y equal to 1 point, but you understand that there is some error. Okay. Now assume that this is the best model. We have selected this, okay, 1.518x plus 0.0305. Now that initial slide, we mentioned that Sam, here's the weather forecast which says we expect 8 hours of sun tomorrow. Okay, so how can he estimate the value, how many value of how many ice creams would be sold? He will put it in this particular equation and he comes to know that it is 12.45. So approximately 12 or 13 ice creams. That's what he'll come to know. Of course, there will be error because you can see there is an error. This may not be the best model, but understand that from this model, if you try to predict the new data, it would be like this. Okay. Now, this is similarly another question. Okay, we can just try it later. So now say for example, this is just some same wave. They have varied the value of theta 1, theta naught is same, and then they have tried different models, and they one of them, that is if you see the figure B is actually a scatter plot of size and rental price. Okay, and then wherever it had W naught as 6.4 and W1 as 0.62. That particular equation we have taken here. Okay. Now, actual points, can you see it? The line is this. Okay. Whereas the points, actual points are like this. See here, here, they're not on the line. Okay. So what are the errors? This is the error. Okay. So we were supposed to have the point here. Like say, for example, we have constructed the line as this particular line shown in the figure. Now, if you use predicting y, like previously what we did, if you try to predict values of y for the particular x, you will actually get it here. Okay, like this. Say we will get it like here. Our prediction would be this x what I am drawing, but actually the point is here. The small circle what is drawn. So there is an error like this. So there is a distance or an error, isn't it? Like this, for all the points, errors would be calculated. Okay. And then the sum square, we square it and add it. Sum of squared errors, we say. So the sum of squared errors should be minimal. That is the best model what we choose. So did you understand what I'm trying to say? So we understand that we have now initially constructed a line. Okay. So assume that we had, say, if you see in the blue square, we can see there are, say, 5 models. Okay. Each is different line. Now we find the predicted value of y. We know the actual value of y. Okay. We find the distance, that is the difference. So then you square it and you add it, the sum of squared errors, that's what we say. And we find it for all of these models. Whichever has the minimum would be the best model. So minimal squared error, sum of squared errors would be the best model when you take regression. Did you understand this much? Do you have any confusion in this? You want me to say what is the squared error, or you understood it?
Understood.
Yeah. Okay.
Ma'am,
Yeah.
ma'am, one doubt here.
Yeah.
Ma'am, actually we are calculating the intercept, no, ma'am.
Yes.
Are we changing it manually after that? If or how it is done?
We have certain, that's what you're talking about. This is just first step, like I am telling, you're talking about this, isn't it? Like, how do we have these 5 different models? That's what you're asking, right?
Yes, ma'am.
How
Actually,
do
we
we
got only
vary?
one.
Correct. So that is what. So our aim only I have told. We have a certain method how to go modify this value of theta naught and theta 1 and finally come up with the minimum squared error. That we'll see in the next class. Now what I just said is we are just talking about regression where we have different lines. Okay, and then we construct. So we have one line and then we try to modify our value of theta 1, theta naught. How we'll discuss in the next class. Okay, it will take some more time. So each parameters would be varied and then our aim is finally reach a minimum squared error. Sum of squared error should be minimal. Is that fine?
Yes, ma'am. Yes, ma'am.
Yeah. So that we'll discuss how we have something called gradient descent method and we'll start with a value and then finally we'll stop, etc. That is there. We'll come up with that. So our intention is we should have minimum sum of squared errors. So that is our intention. So we'll go to that class. So can we just solve this question now? I think you can try it in Excel itself. It will be easy for you. So just try. I think previous example we were just doing it fast. So maybe few would not have finished. We can try this. So this is size of the flat is X variable. So that is our attribute and price is our response variable Y. Okay. So what all we have to calculate? We have to find. So here if you see it is W0, W1. Previously we used theta naught, theta 1. It is all fine. It is all same. Different notations you might see. Okay. Finally everything is actually from the equation of a straight line which is y equal to mx plus. Now you need to find theta 1. How will you find? Sigma xi minus x bar into yi minus y bar. The whole divided by sigma xi minus x, the whole square. Can one of you try? All of you try, not one of you try. All of you can try. Let us see who is getting the answer. I think it's better to do in Excel because you just have to apply the formula and then just drag it. Otherwise, you can use calculator and try. Anything is fine. So somebody should come up with an equation of a straight line. That is your theta naught and theta 1. So I'm waiting. I'll ask you to tell the answer. You can copy this data. 500, 550, 620, 630, 665. It is visible, right? You can copy. I'll randomly call and ask you to say the values. If you copy these values, I can show you the formula. If you have forgotten.
Ma'am, X mean and Y mean I calculate, like, sorry, I mean size of the flat mean and the rental price mean I calculated. The
Okay.
rest I need to do. Shall I tell after everything is done or now itself?
You tell, let us see whether all are getting. I don't have the answer.
723.5, 723.5 is the mean of size of the flat, and then 455.5 is that of rental price.
455.
723.
Yeah, so X bar is 723.5 and Y bar is 455.5. Others are also getting
Yes.
the same value?
Yes, ma'am.
Okay. Anybody is getting a deviation from this X bar, Y bar? I think X bar, Y bar is a very basic thing. Okay, so you can start with Xi minus X bar. Then you can do Yi minus Y bar. You want me to show the formula? Have you all copied the data? I think you have started, so I feel you have copied. Let me just show the formula because in case if you don't remember. So theta 1 is xi minus sigma, xi minus x bar. The sigma is for the whole term. So xi minus x bar you have to find, yi minus y bar you have to find, you have to multiply, then that whole term you have to add. Did someone finish any of the terms? Or I will ask. It's better you continue doing, I will ask. We don't have anything very complex here, just the normal mathematics. But I want to know who all are doing, who are all here, what is happening. Mathuri, are you here? Hi, Mathuri.